Data plane encryption. In this video, I'm going to talk about data plane encryption. You know that in SD-WAN, after the routing exchange with OMP, finally the Ipsec sessions are establishing between VHs. For example, we can have VH1 in one branch and VH2 in another branch connected to, for example, MPLS transport. Okay, VH1 and then VH2. After exchanging OMP routes, finally we should have Ipsec sessions, Ipsec tunnels between these two VH to sending traffic, real traffic, from VH1 to VH2. For example, if here is net A, the service side of VH1, and is here is net B, the service side of VH2, we can send traffic from net A to net B, okay, over this Ipsec session. Okay, but we need to answer an important question, and that is, what is the process of Ipsec session establishment? First, I want to refer to the standard Ipsec that maybe you know and you remember it from traditional WAN or internet. You know that in Ipsec we use some security mechanism. For example, we have authentication, we have encryption, we have, for example, anti-replay mechanism, or for example, integrity check. Okay, but an important point is, for example, if you want to encrypt traffic, what is you needed? Yes, you need the key. In Ipsec, we use some type of keys for example, encryption. For example, in Peer 1, Peer A, traffic is encrypting with a key. This is a key in A, and maybe with this key or other key, the traffic is decrypting in B peer. Okay, we use keys in Ipsec and many types of VPNs. Okay, and because of that, Peer A and Peer B should exchange keys, and the key exchange, one of the process must be completed before the Ipsec session establishment. For example, in a standard Ipsec, we use IKE. IKE, the abbreviation of Internet Key Exchange, is a famous protocol. We have two versions of IKE, IKE v1, IKE v2. For example, between A as a one peer of Ipsec session and B as another peer, you know that we have two phases of IKE. IKE phase 1 and also IKE phase 2. IKE phase 2. In IKE phase 1, we should negotiate some parameters, and finally we establish a secure connection, and as you remember, we named it ISA camp tunnel. ISA camp tunnel. I don't want now explain all of the topics about IPsec, and also I want only review the topics. Because of that, I want to say that in phase 1, IKE phase 1, some parameters are exchanged between two peers. And after that, the first tunnel establishing. That parameters maybe are authentication method, hashing method, and other techniques that we want to use. Okay? This phase is only used to establish a secure channel to negotiate the second phase of the IPsec tunnel. The second phase of IKE establishes a tunnel in which user data is transmitted, IKE phase 2. We are calling this phase IPsec tunnel or IPsec session. IKE phase 1 is ISA camp. IKE phase 2 is the final and real and usable tunnel. The name is IPsec tunnel. Okay? The second phase of IKE establishes a tunnel in which user data is transmitted. For this tunnel to be established, a few things are negotiated. Okay? First, phase 2 of IKE will negotiate the use of an encapsulation protocol, either authentication header or encapsulating security payload. In this phase, we negotiate, for example, authentication header, encapsulation method, or ESP, encapsulating security payload. Next, the encryption algorithm to use, the type of authentication, and the tunnel lifetime will be agreed upon. The various methods supported. Okay, all of these concepts should first negotiate, and after that, IKE phase 2 tunnel is establishing. And after that, we can send traffic in IPsec tunnel or IKE phase 2 tunnel. This is a standard IPsec. But in SD-WAN, we should change this method of key exchange. Why? Assume that you have 6,000 VHs and we want to establish IPsec sessions between these VHs, for example, in fully mesh manner. You know that if we have fully mesh tunnel, 6,000 multiply 5999 tunnel needed. Okay? And for this very huge number of IPsec sessions, if all of the sessions exchange straightly the key exchange, the overhead and the burden of CPU usage in the V8s are very high. Because of that, in SD-WAN, to remedy this, negotiation between the V8s are done in control plane, with control plane of SD-WAN. How? First, look at here. VH1 should send their key to other VH. Okay. The first solution is VH1 send its key straightly to all of the peers. And because of that, it should negotiate straightly with all of the other VHs. Now, in SD-WAN, it can send its generated key to the only vSmart.